Hello everyone, welcome to Chemistry Voyager YT channel. In today's session, we will try to cover all important oxoacids of phosphorus. Let's get started. So before we begin, let us look at what exactly is meant by this term, an oxoacid. So an oxoacid is an acid that contains oxygen, elements like oxygen, hydrogen, and at least one other element. For example, you take the case of sulfuric acid. The formula of sulfuric acid is H2SO4, and this is an oxoacid of sulfur. Why? Because it has got one oxygen atom, one hydrogen atom in the form of OH group, okay, and other element like sulfur. So we call it an oxoacid of sulfur. In the similar fashion, phosphorus has got some good number of oxoacids, and one of them is H3PO2. And this is an oxoacid of phosphorus because we have oxygen and hydrogen in the form of OH group. Also we have other element, that is phosphorus. So we call it an oxoacid of phosphorus. Let us now look at the structures of the phosphorus oxoacids. First and foremost, it is very important to understand that phosphorus has got two types of oxoacids. One is Us type of oxoacids and the second one is Ik type of oxoacids. If you can look at the slide carefully, we have acids like hypophosphorus acid, orthophosphorus acid, and pyrophosphorus acid. And the remaining acids are Ik acids like a phosphoric acid, orthophosphoric acid, hypophosphoric acid, pyrophosphoric acid, peroxomonophosphoric acid, and other phosphoric acids as well. And let us now try to get the basic difference between this Us acid and Ik acid. The main difference between this Us acid and Ik acid is that as Us acids are the ones which has got at least one pH bond. Okay, this is hypophosphorus acid, this has got one pH bond. Also this is orthophosphorus acid, this has got one pH bond. And if you can look at the structure of pyrophosphorus acid, this has also got pH bonds. And if you can look at other structures, in all the cases there are only phosphorus to hydroxy bonds. Phosphorus to hydroxy, phosphorus to hydroxy, all are phosphorus to hydroxy only. So this is the main difference between oxoacids and Ik oxoacids. And when we look at other important points, in number of times in competitive exams they ask you the bonding connectivity in the phosphorus oxoacids. For example, let us look at the acids with phosphorus to phosphorus connection. So in the in this particular list there is only one oxoacid of phosphorus which has got this PP linkage, and that is this particular oxoacid, hypophosphoric acid. And when we look at the another type of linkage, that is phosphorus to oxygen and oxygen to phosphorus, and there are two important oxoacids of phosphorus which can show you this phosphorus to oxygen linkage, that is pyrophosphorus acid and also pyrophosphoric acid. And when we look at the reducing properties of these particular acids, the acids with the pH bond, phosphorus to hydrogen bond, they will act as what? Reducing agents. This is because the electronegativity difference between phosphorus and hydrogen is like this. Hydrogen electronegativity is more than the electronegativity of the phosphorus. Because of that reason, there is always the possibility that they can give you this hydride ion which can act as a reducing agent. And coming to other type of phosphorus oxoacids, we have things like peroxomonophosphoric acid. This is called peroxoacid because we got one peroxy bond here. This oxygen to oxygen single bond is called peroxy bond. Okay. Also we have got some metaphosphoric acid. This is polymetaphosphoric acid. The formula is going to be HPO3 taken n times. It is a polymeric oxoacid. And the last one is cyclotrimetaphosphoric acid, HPO3 taken 3 times. This has got some cyclic structure. And these are the important points which we have already discussed in the previous slide. So as we have discussed, Us acids are the ones that contain at least one pH bond and ic acids are the ones that contain at least one POH bond, and there are only two oxoacids that show phosphorus to oxygen, oxygen to phosphorus linkage, and they are what? H4P2O5 called pyrophosphorus, H4P2O7 called pyrophosphoric acid, and there is only one oxoacid which can show phosphorus to phosphorus linkage, that is H4P2O6, which is called hypophosphoric acid. Also, the oxoacids with pH bonds can act as what? A very good reducing agents. And for if you what is that? For example, you take the case of hypophosphorus acid H3PO2. This is a very strong reducing agent because this has got two phosphorus to hydrogen linkages. Phosphorus to hydrogen, phosphorus to hydrogen. Two phosphorus to hydrogen linkages are there, so you get two hydride ions from this particular compound. So it acts as what? A very strong reducing agent. For example, if this particular H3PO2 is added to an aqueous solution of this AgNO3, that will be converting this silver plus ion into metallic silver. This is an example of reduction reaction. Thank you. There is a small correction note. While counting the number of oxoacids with the POP linkages, that is phosphorus to oxygen, oxygen to phosphorus linkages, I was only considering two normal oxoacids. They are H4P2O5 and H4P2O7. However, there are two more oxoacids with POP linkages. One is this HPO3 taken 3 times, cyclic oxoacid, and the other one is the polymeric oxoacid, that is HPO3 taken n times. Kindly note it. Thank you.